Yeah, good morning from Avanto and HACH company, and a warm welcome to all participants joining us today. Thanks already for taking the time to join us today about our webinar with the topic, an overview of HACH spectrophotometry solutions, which will be given by Philippe Pons. He will give a couple of words about himself just after my introduction quite soon. My name is Frank Krebs. I'm a marketing manager at Avanto, responsible for that kind of equipment we are showing you today. Before we really start, I just want to make you aware about 2-3 housekeeping notes. The first is you don't have to write anything down. You will get the full recording plus all material shared right after the webinar together with a small survey. So don't hesitate to give us your feedback. That will help us to improve and even enhance further webinars in the future. And the second is, if you have, while you are muted, you have the chance to raise any questions you might have during the webinar or at the very end when we have foreseen our FAQ session. And to be able to do so, you have on the top right of your screen an icon, a question mark icon, and that is your area. Whenever you might have some questions, don't hesitate to raise them. I will take them up or put them on the end of the presentation of Philippe that we can verbally answer on all of your questions. So don't hesitate to make use of that question area on the top right of your screen. Having said that, again, thank you. And thank you, Philippe, already for guiding us through that valuable content today. And the stage is yours, Philippe. Welcome.
Thank you. And thank you for attending this webinar. During this hour, we will discuss colorimetric measurements, talking about the different chemistries, and in particular, LCK cuvette test. It's better if I display the agenda. The methods that have recently been standardized, and then we will quickly review the devices that allow this type of analysis to be carried out. First of all, a little bit of theory. What is color? To approach the concept of color, we must understand the concept of complementary color. When we see, I think that I have to disconnect my, no, we'll continue. So we have to see the color or the concept of complementary color. When we see an object of a certain color, it's because this object, when it's illuminated, absorbs its complementary color as represented on this colorimetric circle. If you see, for example, a red object, it means that it absorbs its complementary color, which is the green one. This is important to know because in colorimetry, we will measure the color that is absorbed, which in the case of a liquid sample is the transmitted color. A color is identified by its wavelength. Wavelength is the length between the different waves of the light spectrum. There is a very wide spectrum of wavelengths, but only a small range of visible colors by our eyes that goes between 400 to 750 nanometers. Most analytical methods by colorimetry are done in the visible range. First poll.
Yeah, I will shortly take them up, Philippe. So for the participants, I will launch that poll. So please don't hesitate to give us your answer. And it's launched right now. So what's the measuring principle of photometry? Is that measurement of sample color? Is that measurement of the light absorbed by the sample? Or is that 3 measurement of particles within the sample? So please don't be shy, share your opinion. So results coming in. Let's give another 10 seconds. Okay, that's already quite a feedback in. So 92% are voting for measurement of the light absorbed by the sample, and 8% are in the opinion that the measurement of the sample color is here relevant, Philippe. So I will end the poll.
Yes, perfect.
Thank you for voting.
Definitively, we are champions in the we have champions in this call, because yes, it's definitively the correct answer. We don't measure a color, even if the name of a method is colorimetry, but we measure the light which is transmitted and absorbed by the sample. So just to explain what is the principle of photometric measurement in liquid samples. Most solutions are not colored. To be able to make measurements, we add reagents to the sample that will react with a parameter to be measured by changing the color of a sample. The higher the concentration of a measured parameter, the greater the color change. Then we make a measurement of absorbance at a wavelength which corresponds to the maximum absorption for this parameter. This measurement will allow us to know the concentration of this parameter in the sample. Of course, like a lot of other techniques, a device that measures colorimetry must be calibrated. To do this, the absorbances of several samples of known concentration must be measured and the calibration line must be plotted. The calibration line is characterized by a factor and a bias, because it's a line. And these values are already pre-programmed into the devices for the manufacturer's chemistries. Once the calibration is done, and to perform the measurements, the device does an absorbance measurement through the sample and determine the concentration of the parameter by using this specific calibration line. Different types of chemistry can be used in colorimetry. During this presentation, we will talk more specifically about chemistry in cuvette tests for the laboratory, that we call the LCK, and a particularly innovative field solution, the chemkeys. Measurement with traditional chemistry use liquid or powder reagents and require many manual steps that are highly operator dependent. The quality of the results will be impacted by sample preparation, vial cleanliness, and of course the correct respect of procedures. They need also systematic blanks and require waste management. Now let's talk about different chemistry, cuvette tests, and the benefits it brings over traditional chemistry. In cuvette tests, and depending on the parameters, all or most of the chemistry is already present in the tube where the measurement will be made. This technique has many advantages that we will detail later, but we can summarize as an easy and safety of use, a speed of analysis, and a simplified waste management. LCK cuvette tests exist for a large number of parameters measured in a liquid sample. Whether drinking water, for example, or wastewater, or other types of samples used in different industries. The LCK portfolio allows to measure more than 50 parameters in different ranges, which corresponds to more than 220 methods. Some of these methods require digestion, such as COD, or total phosphorus, or total nitrogen. And some of these methods are also ISO standardized. Why are LCK tests safer? Since all or most of the regions are already in the cuvette, operators are no longer in direct contact with potentially toxic regions. Thanks to the flat bottom that you can see here, LCK tubes stand upright and with a narrow neck, the contents do not escape onto the bench if they are knocked over. The reaction takes place in a closed tube, which limits vapors, especially during high temperature digestion. The COD is the perfect example of this benefit. This COD chemistry requires the use of carcinogenic reagents, such as potassium dichromate, and requires hot mineralization. With LCK cuvette tests, the operator is not in contact with the regions, and the volume of which is reduced by 95% compared to the traditional method. Mineralization and measurement are done in closed tubes, which drastically reduce the risk of exposure to toxic vapors. Other benefit is of use. The pre-filled tubes and any additional chemistry are all in the box to limit handling. A simplified user guide with pictograms and a color code ensures correct compliance with the method. All documents related to the method, such as quality certificates or safety data sheets, can be downloaded directly from HACH website. The simplified handling of the tubes already saves time compared to the classical method. But an additional gain can be obtained thanks to the rapid mineralization of the samples by using the high temperature heating blocks HT200S. For COD, TN, TP, and heavy metals, the digestion time can be reduced by up to 75% thanks to a temperature of 170 degrees and a heating time of only 8 minutes. In order to ensure perfect safety for the operators, the heating block HT200S is equipped with a protective cover that locks until the temperature returns to normal. For accurate results over time, a comparison with a reference element makes possible to compensate. For accurate results over time, a comparison with a reference element makes possible to compensate for the aging of a lamp. The quality of the result is also ensured by the 10-point measurement existing on the DR 3900 and DR 6000 spectrophotometers. What it means? When the tube is inserted, it rotates so that the device makes 10 successive measurements and can eliminate, if necessary, up to 3 abnormal results before averaging the remaining points. This technique eliminates the risk linked to possible defects in the glass or micro scratches that could disrupt the measurement. If there is an issue during the measurement, the instrument will inform the operator by a clear message displayed on the screen. On the DR3900 and DR6000 models, the tests are automatically recognized by a barcode. So the instruments will know the parameter and the measuring range of the test. But the LCK tests have also an extra 2D code, automatically read by an onboard camera, which provides additional information on the chemistry, like the lot number and expiration date, which allow complete traceability of the result, and also the recent TrueCal functionality further improves the accuracy of the result. What is TrueCal? And what are the benefits of a TrueCal function? 8 to 10% of laboratories encounter frequent or occasional difficulties during their quality process due to erroneous quality control measurement results. In order to minimize measurement variation, we have developed the TrueCal function, which automatically adjusts the calibration line according to each LCK production batch. This information is present in the 2D code. Without TrueCal function, the instrument will use the standard calibration curve, which is adapted for all batches, but we will increase the accuracy if we have the TrueCal feature which adapt the calibration curve for each batch. An example. Practical example on an ammonium test. You can see on the graph the yellow curve, which shows the results on a device not equipped with TrueCal. And we note that the variability of the results is lower on the blue curve, measured with TrueCal, which adjusts the calibration curve according to the batch of used LCK. TrueCal is existing for a panel of parameters frequently used in the wastewater. On the DR3900 and the DR6000, optional RFID technology makes it easy to update test data. If significant changes have been made by HACH to the chemistry or calibration of a new batch, when the customer will read the first tube, the instrument will generate a message on the spectrophotometer requesting an update. And at this time, the customer, the operator, simply holds the box up to the RFID reader, and all new parameters will be updated into the meter. I forgot to say that if you have not the RFID sensor on your instrument, because it's an optional feature, you will be able to update via a file download from HACH.com. A very important point concerns the recycling of used tubes. In most European countries, the recycling of cuvette tests is provided free of charge by HACH. The user simply has to put the cuvettes back in their original box and return them to a platform, a local platform in the country, that will send them to our center in Düsseldorf. The tubes and most of their components, such as glass, plastics, chemical, and so on, will be fully recycled in compliance with current standards and an environmental approach that has been validated by several organizations, for example, including EcoVadis. HACH is very proud to participate to this environmental approach, which is also a real financial benefit for our customers who no longer need to manage their waste. Second poll.
Yeah, coming up, Philippe. So our second one for today is which cuvette test methods are standardized, ICO standards? Is that COD, is that TOC, is this ammonium and nitrates, or are there autophosphates or total phosphorus? Please make your best guess. Okay, now it's becoming more difficult, Philippe.
But it's completely
Let's give
normal.
another 10. Yeah. Let's give another 10 seconds. Okay, I start to share. So 65% are for COD, 11% for TOC, 19% ammonium, and 7% about autophosphates or total phosphorus. Thanks for voting. I will stop the poll.
Yes, the results are, I would say, pretty good. Why? Because effectively, COD and nitrogen are now normalized and standardized. And you can see here the certificate. LCK methods are mostly adaptations of standardized methods and often follow the same procedures. But some of them have been the subject of a separate standard. COD cuvette test have already been standardized for many years. But nitrogen methods were also standardized very recently in 2023, which allows for simplified implementation in laboratory. Example of COD, chemical oxygen demand. It is a parameter commonly used in wastewater, in water treatment measurements. The historical standard ISO 6060 recommends measurement by titration after mineralization. COD in cuvette test was also standardized in 2002 under the name STCOD. It is the ISO 15705. And this method, this LCK or cuvette test method, has quickly supplanted the historical method as its benefits are numerous. The method is carried out in 6 steps, and all the regions are all existing in the cuvette test, present in the cuvette test. The operator has only to add 2 milliliters of the sample, which has, of course, to be homogenized because the particles contain COD, and we need also, of course, to have a representative samples regarding particles. But not all COD methods in cuvette test are standardized. The LCI 400 and LCI 500 scrupulously follow all the recommendations imposed by the ISO standard, including 2 measurement ranges and a 2-hour digestion at 148 degrees. We also offer a range of non-standardized COD tests that have several benefits. The measurement ranges are narrower because it's not recommended to dilute samples for COD measurement. It's also recommended to work towards the middle of the range where accuracy is best. Above all, these methods allow to the use of high temperature digestion, which reduce the total time from 2 hours to 35 minutes. Chlorides interferes with COD measurement by creating turbidity that is not always visible to the human eye. Standard LCK cuvette tests have a tolerance for chloride up to 1 gram per liter, and the DR900, 3900 and the DR6000 can detect an abnormal turbidity. For samples with high chloride concentrations, HACH has developed a range of tests that can measure COD on samples containing up to 20 grams per liter. As previously mentioned, a rapid mineralization is possible on non-standardized COD tests. It's very useful if you need fast results for unloading a waste truck, for instance, or because the sample is unknown and you want to get a first idea of the concentration. Now let's talk about nitrogen and its different components. Total nitrogen is composed of organic nitrogen, ammonium nitrate, and nitrites. Some countries use Cheldal nitrogen as part of regulatory monitoring. The ammonium method is simple with the use of dosy cap. Dosy cap is the cap of a cuvette test, which already, okay, sorry, I have definitively to cut my Teams because, okay. I don't know if it works. Okay, now it works. Sorry for that. So I have to come back. Okay. So the ammonium method is simple with the use of dosy cap, as I said. And dosy cap is the cap of a cuvette test which already contains a reagent in the form of the lyophilized tablet. LCK exists in 7 ranges, from 0.015 to 1,800 milligrams per liter. We have developed 2 recent ranges, 0.525 and 10 to 100 milligrams per liter, to ensure better overlap of the ranges and to allow to measure with maximum accuracy the samples around 2 and the samples around 50. Ammonium is very sensitive to temperature. And as you can see in the graph, the results can be different according to the regions, sample, and/or environment. If you can measure at the optimum temperature of 20 degrees, the DR3900 and the DR6000 can automatically correct the results if you introduce the sample temperature. The nitrate method is carried out in 5 steps without any addition of additional reagent. It exists in 3 ranges, from 0.23 to 150 mg per liter. The measurements of nitrates is sensitive to chloride if their concentration is above 500 mg per liter. If dilution is not possible, a specific silver chloride kit, as you can see here, can eliminate chloride. The measurement of total nitrogen requires the use of two separate tubes. One is used for the mineralization of a sample, and the second will contain the chemistry necessary for the measurement. Here too, everything is in the box. You can choose the classic mineralization, which lasts 1 hour, or the rapid one in 15 minutes if you have the high temperature heater HT200S. To increase the measurement range, we have just launched a new test which goes from 100 to 150 milligrams per liter. But several European countries have to measure gel-dye nitrogen for compliance and not TN. The traditional gel-dye method requires to make a distillation using a complicated glassware or a specific instrument and measure distilled ammonia by titration or colorimetry. LCK offers a simpler alternative by measuring TN and nitrate on a preserved sample, a sample which has been acidified, and using the formula by calculating TKN, total gel-dye nitrogen, equal total nitrogen minus nitrate. If there are nitrites in the sample, they can also be measured and subtracted as well of the TN. I would like also highlight another topic and take this opportunity to introduce you to the LCA 722 kits. Using QV test requires the use of a pipette, and volume accuracy is important for accurate measurements. Your spectrophotometer can also help you to check your pipette. Simply add a set water volume in the QV test based on the pipette volume you need to check to your LCK 722 tube and perform a measurement. The spectrophotometer will tell you if the expected volume is correct based always on the transmittance measurement of the colored sample. Now, let's do a quick introduction to the devices that we can use to measure by spectrophotometry. We offer two families of instruments. First, photometers, that we can call as well colorimeters, which operate with one or a few fixed wavelengths adapted to the parameter that we want to measure. The wavelengths are selected by means of filters. The second family is spectrophotometers, which can work on multiple wavelengths thanks to a prism capable of decomposing light into multiple wavelengths. The wavelengths required for the parameter to be measured is selected by the wavelengths required for the parameter to be measured is selected by a grid. We offer two photometers, the DR300 and the DR900, and an hybrid photometer, the SL family, which we will discuss later. These are simple and essentially portable devices. They only work in the visible range and use classic chemistry, liquid or powder, but not LCK. They allow rapid measurements, but the manual sample preparation and the classical chemistry used make measurements very dependent on the operating mode, so very dependent also of the operators. The SL family uses a very different chemistry called the ChemKeys. Regarding the spectrophotometers, we have three models. They all allow the use of LCK cuvette test in addition to classic chemistry. The portable version, the DR1900, is more limited than the laboratory versions and does not have barcode reading, 10 points measurement, or the TrueCal function. The DR3900 and the DR6000 are both benchtop spectrophotometers that offer advanced features ensuring the highest quality measurements, maximum ease of use, and complete traceability. The DR6000 also allows measurement in the UV and offers a better wavelength resolution. The DR3900 and the DR6000 allow complete sample traceability and guarantee high-quality results. They will guide the user through their simple menus and clear message. They can export results automatically to a USB key or to a LIMS with its intermediate corrections. They have in common several advanced features that we have already seen, like 2D barcode, 10 measurement, and RFID, and extra features that I present in the following slides. We have seen the use of the RFID function for updating methods by presenting the box in front of the device. But RFID is also used to simplify the sample management. Thanks to the lock 100 and RFID labels stuck on the sample bottles, the operator can automatically enter his name, the name of the sample, the collection location on the plant and the date, and back in the laboratory, all he has to do is to pass the bottle in front of the device to transfer all this information to the meter. Other features, the ratio mode. The ratio mode can compare automatically 2 or 3 parameters on the same sample and at the same location to check if the results can be considered as normal or abnormal, according, of course, customer limits. A good example is the nutrient ratio in wastewater between carbon, nitrogen, and phosphorus, which must be ideally 100, 5, and 1. If these values are too far away of the expected one, the instrument will give you an alarm. During the measurement of a parameter, if there is a risk of interferences due to another parameter which has already been measured on the same sample, the instruments can display an alarm message. The instruments use the interfering tables, which are described in all LCK methods. It can prevent false or underestimated results, like we can see, for example, on this slide, with the risk of chloride interference on the sample that you want to measure. For a complete quality assurance, the DR3900 and DR6000 combines several features, including a complete quality control management, control charts, standards, and HACH-proof tools. As a part of the quality control of instruments carried out by users, HACH offers a range of ADISTA quality controls that allows to control several parameters with the same standard solution. These solutions are delivered with a bottle with known expected values and 2 other bottles with unknown values. The operator can measure these 2 solutions and send the result to HACH for verification. And he will receive later the results compared to other customers using the same instrument. it consists in a free round-robin test between customers. On these slides, you can see as well an example of range control chart, which can be generated by the instrument with all required information at a glance for a perfect quality control process. Quick presentation of the DF3900. I would say that this is the reference device for user working only in the visible from 320 to 1100 nanometer. The 300, of course, is the instrument, is this one in the middle. It is equipped with all the advanced features such as RFID, to decode, through call function, 10 points fold, and so on, and quality control management. It can also be equipped with a pump module to make measurements with a flow cell. The DR6000 has all the same benefits of the DR3900 by adding measurements in the UV spectrum. So it means that its range is from 190 to 1100 nanometer. It has a best wavelength resolution, 0.1 nanometer instead of 1 nanometer, for finer scans. It also has a small 7-position carousel for small series of automatic analysis and also allows the use of a flow cell. And the DR6000 offers as well optional application kits for very specific methods, as you can see on the screen. We have 3 different software packages. One is for application software enzymatic food analysis. It is a compilation of tests manufactured by Biopharm AG. We have a second package for brewery. So this application software is a compilation of 12 brewery assays that we can measure directly on the DF6000. And the third one is specific application software for drinking water. And it's a compilation of all methods that are relevant for drinking water analysis. And the LCK cuvette test can be also automated. The AP3900 robot can automate the complete analysis process of your sample with LCK, including pipetting and digestion. So these robots exist in COD only or multi-parameters version, and with more than 12 years of expertise in automation of cuvette tests, HACH provides a reliable solution for customers who have a large number of samples and want to save time. Now, presentation of a SL range and chem keys, which is an hybrid instrument with definitively a revolutionary method for measuring parameters. The SL series is a very innovative concept that combines a colorimetric measurement using a unique analytical technique, which is called ChemKeys, and a multiparametric device that uses electrochemistry probes to measure pH, conductivity, dissolved oxygen, and so on. The ChemKeys eliminates all the disadvantage of classic chemistry. And the SL series combines 2 instruments in one to measure several parameters at the same time. How do ChemKeys work? one chem key is used to measure one parameter in one sample. The sample is drawn into the chem key and circulates through the capillaries that contain the dehydrated regions needed for the chemical reaction. The sample then enters the measurement chamber, where the analysis is done at the wavelength corresponding to the parameter. After the measurement, the chemistry is neutralized at the top of the chem key, which allows the chem key to be treated as an inert waste that you can put directly in the trash box. The benefits of chem keys are multiple. Measuring vials and sample preparation are no longer necessary. Once the sample is aspirated into the chem key, the different steps of the method, the timing, and even the temperature of the reaction are entirely managed by the device. The results are completely independent of the operator, and chem keys reduce measurement variations due to operators by 90%. And the SL range also saves time, a lot of time. The SL250 model has 2 channels for electrochemical probes and 1 single channel for chem keys. It allows 3 measurements to be made in parallel. The SL1000 also has 2 channels for electrochemical probes, but 4 channels for chem keys. So it allows 6 parameters to be measured in parallel. You can see in this slide the powerful of this technique with the example of a common panel of analysis on drinking water. For 6 parameters, the classic equipment requires 30 minutes and 2 different devices. An SL1000 will do all these analyses in 8 minutes and with only 1 single device. For electrochemistry parameters, the SL range use the same Intellical digital electrodes as was used by our HQ series of meters. What are the benefits of the Intellical probe? First, these probes are digital, so it means that you don't need to take in consideration the length of a cable. You can measure until 30 meters if you want. And all the calibrations are stored into the probe. So it means that if you calibrate a pH probe on one instrument, and if you use the same probe on another instrument, the calibration will be automatically considered in the new instrument, and it's no more necessary to calibrate again. Of course, if the calibration of the probe has been recently made on the previous instrument. And with this kind of probe, as soon as you connect the probe on the instrument will recognize automatically which kind of parameter you want to measure. And if the instrument have two, and like the instrument have 2 ports, you can mix as you want the different probes on the 2 ports. What are the parameters available with chem keys? Of course, we have not all the parameters available for the chem keys. So we have a selection of parameters, and we have to take in consideration that with chem keys, we are working in micro method. So it means that the volume of the sample is minimum, is very small. So it means that we have to use, and you can use chem keys on clean, particle-free, and only slightly colored wastewaters. If not, if we have too much particle or too much colored sample, the SL1000 are not adapted for these kind of samples, and you have to use the classical methods. Thank you. It's done. Do you hear me?
Yeah, Philippe, I can, and I think we can hear you very well. So thanks for the presentation, Philippe. We followed quite closely. So I'm just checking for the question to in the chat. Let me just look at that one. Receive some questions. Yeah, there is one. Yeah, you mentioned COD, Philippe, but we were considering replacing this parameter with TOC. Can it also be measured via the LCK system?
Yes, it's a very interesting question because we see definitively in Europe a trend to try to replace COD by TOC because, of course, the chemistry used by COD is dangerous. So it means that there is this trend in Europe, and for example, in the Netherlands, the process has definitively started, and it should be the case in the 2025 or 2026. So it's really a process which is on the way. So to answer to the question, yes, we can use LCK for measuring TOC, because for TOC, we have two different methods. The first one is called NPOC, so it means that we remove TOC, we purge TOC, and we measure the TC, which will be the TOC. It's the purging method called NPOC. Or we have another method which is made by difference. So it means that you measure TIC, you measure TC, and you subtract TIC to TC to get the TOC. So the two methods exist on the LCK. It works very well, but it's not really adapted to a large amount of sample because you need tube tubes and so on. So for laboratory, which have a large number of samples, we have also another technique, which is an analyzer called QP1680. And this analyzer is a pure analyzer for laboratory with 65 samples and so on, which use the catalytic method, which is standardized. So you have a choice, but yes, for TOC, it works with LCK as well.
Okay, great. I just answered one participant, but maybe that's important for all the participants, that you can have a certificate or confirmation of participation in that webinar. Yes, of course. We will organize that, and if you need it as well, please just give us a mail on the webinar@avantosciences.com, and I'm happy to help you out with that confirmation of participation. So I got another one, Felipe. Is it possible to measure sulfates?
Yes, that I wanted to check. Yes, we have sulfate. We have two ranges for sulfate. So we use the method with barium sulfate, and we can measure between 40 to 900 milligram per liter.
Okay, super, great, Felipe. I think that answers the question. Yes, it's possible. Just arriving another one. You have mentioned the HT200S heater that can digest as a faster rate, I believe at 107 degrees Celsius, of course. Will this can be used for the existing COD LCKs where the requirement is 2 hours at 148 degrees Celsius?
Yes, you can always use the fast digestion with the LCI methods, but of course, if you do that, you can consider that the measurement that you will do will not follow the norms. So it means that you can do. You have also to check the value to control the value as well, because you use a method which is slightly different of a method recommended by the norm. But of course, you can do. But if you want to use fast digestion, and because you will lose the standardization if you reduce the time of mineralization for the LCA ISO cuvette test, I would recommend to use the other range of standard of COD test, which is definitively calibrated for a fast also digestion.
Okay, I hope, and I'm sure that that answers the question. And I say, if not, we will answer and come back to you offline out of the webinar. Just checking again the question area you receive. So our last one, as we just have 4 minutes to go. Can we use our own colorimetric methods on your spectrophotometers? I guess that is an interesting question, Philippe, no? So can a customer use his own tests within your equipment?
Yes, I would say that on the instrument, we have, I would say, at least on the DR3900, I discussed about the spectrophotometer definitively and dedicated to the benchtop. I would say that we have 3 different families of methods. You have LCK method, so it means that as soon as you put the tube in the instrument, it will recognize automatically the parameter, the range, and you can perform immediately the measurement. There are also the other chemistry, which are not using LCK, so it means it's a classical chemistry. And in this case, you have to select in a list of methods which is already pre-programmed in the instrument. You have to select manually the method that you can use, and you start the measurement by using the internal calibration line. But you can as well have what we call users methods. And with this method, you can create your own calibration line to perform your specific measurement with your chemistry and to create your own methods. So it's also possible on the instrument, and you will select this method in the list of the methods, and because this method will be added in the list of the methods.
Okay, cool. Sounds like a plan, Philippe. So another, and I fear the last question is, what is the lowest range of COD LCK in salt water?
I can show you.
I think I read that as well.
Yeah, where is the slide? Like that, you will have all the range. You can see here all the range because we have 2 different kind of COD dedicated to salt. We have a range, this one with a tolerance of 4 milligram, and it starts at 100. And we have the range for very high, I would say, salty samples, up to 20 grams per liter of chloride. And for this range, we start at 7 milligram per liter. And we go until 1 gram per liter.
Okay, super. Thank you. And I see we are at time, Philippe. So thanks already to the audience for joining today. And if you have any questions left, and we all know that they will come in the daily work, don't hesitate to get in contact with your Avantor sales representative or write me an mail under webinar@avantorsciences.com. Happy to forward that to our sales force and the experts from HACH to give you all the answer you might need in your daily work. Again, just the housekeeping notes, you will receive the recording. That recording will stay on our event page for at least 1 year. So if colleagues are interested, make them aware that on the event page at vwr.com, beyond webinars, they can recheck all the recordings, and you will receive them in a follow-up mail together with a small survey. Don't hesitate to share your opinion about how you feel or you felt during that webinar, what can be improved, what was great as well. So please don't be shy and share your opinion about that one as well with us. So having said that, I like to thank you, Felipe. I guess it was a great presentation. And as said before, if any questions are left, get in contact with us. Happy to answer all your questions. And I wish you now all a great rest of the day, and take care as always, and see you next time. Thank you.
Thanks a lot, and thanks for attending.
Bye-bye.